Okay, so we worked with two-dimensional figures and we talked about perimeter a little bit and circumference. So now we want to talk about the next step in calculating different things with two-dimensional figures before we move into three-dimensional figures. So along with the length of the outside of a figure, we have what's on the inside of the figure. So today we're going to talk about area. Now, there's a lot of formulas that you're going to have to memorize for this. And yes, you can look them up. And if you were taking the Regents test, some of them would be given to you. But as you go on your mathematical career, you're going to be expected to know these formulas, okay? So even though you may not have to memorize them right this second, you're going to have to know them later. So don't be surprised. You might as well start learning them now. Some of them you already know. So let's first talk about what the heck area is. So area is a measurement of the space inside a figure. And we mean a two-dimensional figure here, okay? Some people even say, another way I've seen the definition of area written, it's the number of 1 by 1 unit squared blocks that fit inside a figure. Okay, so if you're going to tile a figure, okay, if you're tiling your bathroom floor, that basically you're covering the area. And you can actually buy 1 inch by 1 inch tiles or 1 foot by 1 foot tiles and cover a floor. Now, when you're doing that, maybe you use a full tile, maybe you don't. So that even the area, we can talk about not the number of tiles being a whole number, but sometimes a partial of the whole, okay? So that's what area really is. It's covering over an area, a space, an area. So different formulas that we need to know. Area of parallelograms. When we talk about parallelograms, we talk about some different types of parallelograms. We know our basic parallelogram kind of looks like that, okay? But then, hey, if you take this parallelogram and create some right angles, now that parallelogram is a rectangle. If I were to make right angles and all the sides the same, that parallelogram is now a square. So all of these parallelograms basically have the exact same formula, okay? The area of a parallelogram, for all parallelograms, the area equals base times height, the length of the base times the length of the height. Now notice some things I'm doing here, okay, when I make my notation. I use capital A for area, okay? Don't get that mixed up with a capital A used for point A or angle A. We have to take context into consideration whenever we're looking at equations. B, I'm using a small b here. That's going to become important later. Lowercase b stands for the length of the base. Lowercase h stands for the height, okay? Now, some people say, but wait a minute, that's not right, because if I'm looking at a rectangle, it's not base times height, it's length times width. So you may see a formula that looks like area equals length times width. But remember we said that dimensions can have different names? When I name this length, well, that's the same thing as a base. When I name this width, that's the same thing as a height. So they're the exact same formula, even though they're using different words. What it means is one dimension times the second dimension. In a square, it even looks more different because the area could equal s times s in this case, or simply s squared. So even though these three formulas all look different, they actually are the exact same thing, okay? They're all a base times a height, okay? Now, you do have to remember that the base and the height must always be what? From our earlier studies, you should have known that a base and a height must always be perpendicular. or must always be a right angle, okay? You've got to make a right angle. We said that dimensions, every dimension has to intersect at a right angle. We said that in our last lesson. So these are just two dimensions in the figures that must intersect to form right angles. That's important because you never want to say, looking at a figure like this, that there's the height, because that's not forming a right angle. So sometimes you'll see a dotted line in there because it's not actually part of the parallelogram, but it's something that we can measure, okay? So simple stuff like that. Now our triangle is a little different because if I were to take this height, I'm just going to sort of do some fun stuff here. Okay, let's take this piece here. Let's just cut through here like that. Notice what happens. I've created two triangles. So the area of part of this, if I were just to shade in part of it, let's get my highlighter here, and I'm finding the area of just this part. Well, that triangle is half of the rectangle. So that formula for the area of a triangle comes directly from the area of a rectangle problem. The formula for the area of a triangle, the area will equal half. Instead of length times width, we call it base times height. Okay, and that's a formula we've talked about earlier in the year. Again, your base and height must make right angles. So in this first triangle, my base is all of the bottom here. My height is here. Now, base does not mean bottom. If I take this triangle and turn it around, now my base is this way, and there's my height. How do I know? Because of the right angle. Okay, you don't have to have base on the bottom. I could call this my base, but then I'd have to have another height here. And that I don't know. So look for the ones that make right angles. If you have a right triangle, the base and the height are the legs of your right triangle. So that makes life just a little bit easier. So again, remember, for area of a triangle, it's actually half the area of a rectangle. So half the base times height. When we go into other figures, whoops, wrong button. When we go into other figures, like a trapezoid, it gets a little more confusing. Some people like to break this trapezoid up, and I've seen a lot of people, instead of dealing with trapezoids as a formula, break it up as another height here. So now I've got some different triangles. I've got two triangles. I got a triangle here and a triangle here, and then some sort of rectangle in the middle. I'm not sure it's a square, but I know it's a rectangle. So finding the area of the rectangle would be B1 times H. That would give me that. The triangles are a little more difficult though, because I don't know what this base is. I don't know what that base is. I got the heights. If I knew these, hey, not a problem. I could figure out the rest of this. So what we end up having to do is we've gone through and created a formula. So rather than lead you into how this formula is created, if you want to do that, come to one of my Q&As and I'll explain that to you. But if you want to just know the formula, the area of a trapezoid is going to be equal to 1/2 the height times base 1 plus base 2. Okay, so it looks almost like a triangle formula, and half base times height, except there's two bases. So we add the bases together. So that's our formula for trapezoid. Now, what you'll see me do sometimes is you'll see me put a little word under area. So I'll call that area of trapezoid. Maybe I'll put a little triangle here for area of triangle. Up here for the parallelogram, let me go back up here to parallelogram. Maybe I'll put a little area of rectangle here, or square here, or parallelogram here, just so that I can differentiate my areas rather than just have A all the time, especially if there's more than one shape. Okay, if it's a composite shape made up a bunch of different shapes, I need to break up my areas and label them properly. Okay, so there's our formulas, and those are the basic figures that we need to know. Are there other figures? Sure there are, but those, if you stick with the rectangle, triangle, and trapezoid, or really parallelogram, triangle, and trapezoid, you can basically figure out most polygons. Now, circles, they're a little different. Area of a circle, this is some people love this formula. This is the formula people repeat every time they hear the word circle. So the area of a circle is pi r squared, because my radius is there. Now it's still 2 dimensions, because if you think about it, my 2 dimensions that we're dealing with are radius and radius. So basically it's kind of like looking at a height and a length. Okay, if you continued on, there's my right angle. So that's how we'd sort of come up with this circle formula. Okay, there's a whole thing that goes into it of how they came up with this. Archimedes did a lot of crazy things to come up with it using calculus. But basically, that's what this is. So my 2 dimensions in this, instead of length and height, are radius and radius. Okay, so that's our formula for area of a circle. But what if it's not the whole circle? If it's not the whole circle, we got to look at a proportion. Okay, now remember, proportions are fractions that are equal. So a fraction, let's get my pen back. Some kind of fraction equal to another fraction. And the way we're going to figure out this area of a sector is just part of the circle, is I'm going to take the area of the whole thing. So that's pi r squared. That's the entire area. It's going to be the area I want. So I'm going to call that A for the area I want. Okay. Now, what do we know about circles? I know that circles, the angles are 360 degrees. That's the whole circle. But the part they gave me here is my theta, whatever that angle is. So what we're looking at is on this side, I've got the whole circle. And on this side, I've got the sector of the circle. And on this top of it, what I use for my numerator is my areas, and my denominators are the angles. So I'm just setting up proportions. Now, there's multiple ways you could set this up. You could also set this up as part over whole. You could do, in fact, that's actually what I've got here is the part over the whole. So I could set this up as the part of the sector, so the part of the area over the whole area, the part of the sector over the whole sector. So areas and angles. These proportions say the exact same thing. Just make sure you match things up. In this case, what I've got is I've got the areas on one side, the angles on the other. But I've got the parts on the top and the holes on the bottom. Okay, so using these formulas now, all these different ways to look at it, we want to now calculate some areas. So first problem, determine the area of this figure here. So immediately looking at it, what formula for area are you going to use? So hopefully you said, I'm going to use area equals base times height because it's a parallelogram. My base is pretty simple. I'm going to get a little bigger figure here. My base is all of that. Okay, so my base is pretty easy. That's 15 plus 5, which is 20. But what about the height? The height is here, and I don't know it immediately, but we know things about this. Look at what kind of triangle you're dealing with. What kind of triangle do you see here? Hopefully you were able to notice that this is a 45, 45, 90 triangle, which means the legs of the 45, 45, 45 are congruent. So there's my 5. So my height is now 5. Therefore, my area is what? So you should get the area is 100 centimeters squared. Now, centimeters squared is my units here instead of centimeters. The centimeters squared tells me that there are 2 dimensions that you're dealing with, a centimeter and another set of centimeters. That's what centimeter squares tells me, is that there are 2 dimensions. Okay, you're not squaring the 100. Okay, the squared number, this exponent, is not on the 100, it's on the units. So that centimeter squared is what's happening. Okay, let's look at another one. What shapes do you see here? Hopefully you were able to say, I see rectangles or squares or something of that nature. And I can break this up. Now, how you break this up is really up to you, but I'm going to break it up across this way. Okay, because if I do that, then all these places that have a dash mark are all measurements of 2. okay? In fact, this space in the middle is also a measurement of 2, which means all the way across here is a measurement of 6. So now I have 2 separate rectangles. I have one rectangle, I'll call it area number 1, that is 2 by 6. So area number 1 is, whoops, why did I put 2 equal signs? Area number 1 is a measurement of 12 squared centimeters. Area number 2, okay, so now area number 2 is going to be this area in here. So area number 2 is now 6 by 2 as well. So that's going to give me an area of 12 centimeters squared. So my total area, I add those together, is 24. Ooh, that's terrible writing. Let's fix my handwriting here. Is 24 centimeters squared. And there's my area. Excellent. Okay, let's try a triangle. First of all, what formula are you going to use? So you chose to use area equals 1/2 base times height. Okay, what's the base? What's the height? So hopefully you're able to look at this and go, hey, wait a minute, I know my base and height have to make right angles. So there's 2 pieces that make my right angles. So that means my base is 12 centimeters. My height is 5 centimeters. Okay. Therefore, giving me a solution of, hopefully you're able to do basic arithmetic and get 60 centimeters squared. Okay. Another triangle. You know what? See if you can find the base and height. Okay, so we're using our formula. The base is pretty easy, right? My base is going to be 10 centimeters. The height, however, is a little more difficult to find. But look at what we've got created here, okay? Let's get the red, highlight this in red. I have a triangle right there. That's a right triangle, and this piece is 5. How can I calculate the height of that triangle? Okay, can't use trig because we don't have angles, but we can use Pythagorean theorem. 5 squared plus h squared equals 13 squared. So what did you get for h? I believe it's 12. Yeah. So you should have gotten 12 for your height. So now that I know my height, I can go back and put all that into my formula. What is the area of this triangle? So you calculated 1/2, base of 10, height of 12. Make sure you use 10 for the base. That's where people make their mistake. They get stuck with the half, the part of the triangle they were looking at in red. So that's going to be 60 centimeters squared. Okay. So we've seen some different things here. Let's take a look at the trapezoid because we haven't looked at one of those yet. So here we go again. Trapezoid. First of all, which formula is the formula for area of a trapezoid? So my area of a trapezoid formula is area equals 1/2 the height, base 1 plus base 2. Okay. So height. What are the height? What are the bases? So base 1. This is where people can get a little messed up. It doesn't matter which one you call base 1, base 2. I'm going to let this be my base 1. I'm going to let this be my base 2. Okay. So putting that into my formula, base 1 is 14. Base 2, be careful, 18 plus 6. So that's going to be 24. Now we need the height. Again, here's my height. Okay, it makes that right angle. But it also makes my right triangle. In fact, sometimes you'll see some of these problems where they'll put the height, instead of putting it there, they'll put it right in the middle here. All you got to do is move that height over and make your own triangle. Okay, so yeah, don't be afraid. If they put that there, yeah, slide it over. So look out for problems like that. So in this case, you should get a height of what? Hopefully you were able to calculate this and say, oh, my height is going to be 8 centimeters. Okay, so now I can set that into my formula. So that means I'm going to go off to the side a little bit here. Area is 1/2 of 8 times 24 and 14 should give me 38. And we can calculate that all together. I'm going to go to my calculator and I get 152 centimeters squared. Okay. Circles. Okay. Circles keep coming around every time. So looking at my circle, what's the area formula for your circle? Okay. So the area formula for my circle, good old pi r squared. My radius is going to be 4. So in terms of pi, what is the area of this circle? So in terms of pi, 16 pi centimeters squared. Be careful, remember 4 times 4 is 16, not 8. So there's my area. Very simple problems. One more, and then we'll be ready to move on to our own. So here we've got a sector, okay? So what's the area formula for sectors? So I set up my area formula. Let's see, I'm going to set up however I decide to. So the area over the entire area, pi r squared, and the sector angle over 360. Okay. So that means I can do my area is what I'm looking for. I don't know that. I do know my radius. My radius is 9. I know my angle is 120, that central angle. And now we're set to solve it. So go ahead, solve for A in terms of pi. Able to cross multiply. Now 9 is actually 81. So that becomes, when I cross multiply, 81 times 120 gives me 9,720 pi. Don't leave off that pi. A lot of people leave that off for some reason. They're like, oh, I'll put it on later, and then they forget. Okay. Now I'm just going to divide by 360. So my area equals 27 pi centimeters squared. Okay. So there you go. You've got some problems to work on. We're going to do a quizzes today for some mixed problems. Be careful. Write out your work. Pay attention to directions. If they say in terms of pi, leave in terms of pi. If they say round, you round. And go for it. Okay. Next day of lessons, we're just going to mix all this up and practice with this. Have a good night.